Hi, today we are going to discuss about introduction to binary trees. In this, we are going to learn what is a binary tree, what is a root node, what is a leaf node, what is a non-leaf node, what is the level of a node, what is depth or height of a binary tree, what is a strictly binary tree, what is a complete binary tree, and what is a perfect binary tree. Figure shows a binary tree. There is a node called A, which is called root node. This is a root node, and it is having two children B, C. Again, B is having two children D, E. C is having two children F, G, where D, E, F, G are not having any children. The node which is not having any children are said to be leaf nodes. Leaf. So D is a leaf node, E is a leaf node, F is a leaf node, G is a leaf node. So these four are leaf nodes. And the nodes which are having children are said to be non-leaf nodes. These are non-leaf nodes. A, B, C are non-leaf nodes, where A is root node, A is parent of B, C, or B, C are children of A. In the same fashion, B is parent of D, E, and D, E are children of B. C is parent of F and G, and F and G are children of C. Definition of a binary tree. Binary tree is either empty or it consists of a node called root node together with two binary trees called left subtree and right subtree. Left and right are again binary trees. Let me explain this with examples. Say, for example, in the example 1, it shows a binary tree where A is root node, A is having a left subtree and right subtree. So left there are three nodes. These three nodes forms again a binary tree. And right side there is only one node. Again you can say it is a binary tree. So A is root node. A is having a left subtree, and A is having right subtree. So a node is there, root node. Root node is having left subtree, right subtree. Left is again binary tree where again see B is root of subtree, D is left of root, E is right of root. In the same fashion, C is root for the subtree, and left of C is null, right of C is null, where the definition is binary tree is either empty or it consists of a node called root node. So it is a root node, left side it is a subtree, it may be null, it may be null. Right side it may be a binary tree or it may be null. So even null is also you can consider as a binary tree. See example 2. Example 2. A is root node, A is having a left subtree and A is having right subtree. Left side there is only one node. Say it is root of left subtree. Left of B is null, right of B is null. So it forms a binary tree. Then what about right of A? It is having some number of nodes where C is root of subtree and D is left of C, E is right of C. So this is one subtree and this is another subtree. Again, these are binary trees. So example 2 is also a binary tree. Example 3. Now, example 3. Where A is root node, A is having left subtree and right subtree, but left is null. There are no nodes. Here C, there are no nodes in the left side. E, there are no nodes in the left side. E, G, there are no nodes in left and right also. So G is leaf node, A is root node, A is having left subtree and right subtree. Left may be null. Maybe you can call it as a binary tree because the definition itself tells that binary tree is either empty or it consisting of a node called root node together with left subtree and right subtree. So this also you can call it as a binary tree where it is root node. Left side there is a left subtree, right side there is a left subtree. It forms a binary tree. So let me explain how to construct a binary tree with some number of nodes. Say, for example, if there is only one node to construct a binary tree. So we are going to construct a binary tree with only one node. So that node becomes root node. Left side is null, right side is null. So a binary tree with only one node, that node becomes root node. Left side there are no nodes, right side there are no nodes. There is only one node in the binary tree, so it will be as shown here. So A is root node, left side there are no nodes, right side there are no nodes. Now you can say this is a binary tree. Suppose if you wanted to construct a binary tree with two nodes, one node is its root node, the other node may be its left subtree, or it may be its right subtree, like this. Say, for example, A is root node, B may be its left subtree, or A is root node, B may be its right subtree. So with the two nodes, you can construct two different binary trees like this. This is one example, and this is another example. A left of B, A right of B. For example, three nodes. If there are three nodes and you are asked to construct a binary tree ABC, say there are three nodes ABC, and I wanted to construct a binary tree. So there is so many different possibilities. See here, the first one, A. A is root node, B is its left subtree, and C may be its right subtree. B left is null, B right is null, C left is null, C right is null. So PC are leaf nodes, A is root node. Or A may be its root node, B may be its left subtree, and C may be left of B, where right of A is null, right of B is null, right of C is null, and left of C is also null. So in this way, you can construct a binary tree. Or there is another possibility: A is root node, B is its left subtree, and C is right of B, where left of B is null, right of A is null, left of C is null, and right of C is null. Now this is also a binary tree where A is root node. It is having two subtrees B, and right is null. Null is also you can consider as a binary tree. The same fashion, another possibility: A is root node, B is its right subtree, and C is left subtree of B. So this is also one of the example. And another example is A is root node, B is its right subtree, C is right of B. Now left of A is null, left of B is null, left of C is null, right of C is also null. So this is a binary tree, right? So everywhere there is a maximum of two children. There is a maximum of two children. So a binary tree may be either empty or it consisting of a node called root node together with two binary trees, left subtree and right subtree. So left may be null or left may be a node. Right may be null, right may be a node. So in this way, we can have five different binary trees if there are three nodes. In this fashion, if the number of nodes increased, automatically the total number of different possibilities also going to be increased in construction of binary trees. Level of a node in a binary tree. The level of a node in a binary tree is defined as follows. The root of the tree has level 0. The root node has level 0, and level of any other node in the tree is one more than the level of its parent. One more than the level of its parent. See here, with an example I am going to explain. So this is the example where this is a binary tree. A is root node, B is its child, C is its child. So B is left child, C is right child. And the same fashion for B, D is its child, E is its child. So B is child of A, C child of A, or A is parent of B, A is parent of C. In the same fashion, D is child of B, E is child of B, where B is parent of D and E, like this. Then Leaf nodes are D is a leaf node, E is a leaf node, H is a leaf node, G is a leaf node. And all other nodes are non-terminal nodes. These are terminal nodes and all other are leaf nodes are terminal nodes. All other nodes are non-terminal nodes. What is a leaf node? Leaf node is a node which is not having any children. Leaf node is a node which is not having any children. Then level. Level of root node is 0. See, level of A is 0. Level of any other node is 1 more than its parent node. So if I wanted to get the level of B, I should know the level of its parent. What is the level of its parent? Parent is A. A level is 0. So level of B is 0 plus 1. 1. What about C? The level of C is 1 more than its parent level. What is parent A? What is the level G? 0. 0 plus 1. 1. Then what is the level of F? Level of F is 1 more than its parent level. Its parent is C. Its parent level is 1. 1 plus 1. 2. So at this level, there are 4 nodes. For all these 4 nodes, the level is 2. Then next H. Level of H is 1 more than its parent level. What is its parent? F. What is the level of parent? 2. 2 plus 1. 2 plus 1. 3. Level of H is 3. So here in this particular binary tree, there are 4 levels: level 0, level 1, level 2, level 3. Level 0, there is only one node. Level 1, there are 2 nodes. Level 2, there are 4 nodes. Level 3, there is only one node. So level starts with 0. Root node having level 0. Any other node having level 1 more than its parent value. Height or depth of a binary tree. Height or depth of a binary tree is the maximum level of any leaf node, because the leaf node is the last node of the binary tree. The maximum level of any leaf node of a binary tree. This equals the length of the longest path from root node to any leaf node. The depth of the above binary tree is 3. See here, in this example, A is root node, B, C are left and right subtrees. There are so many nodes. Let us find the level of all the nodes. Level of root node is 0. Level of B or C is 1, because it is the level of B is 1 more than its parent. Parent is A. A level is 0. 0 plus 1. 1. Or for C also 0 plus 1. 1. So level of B or C is 1. Level of D, E, F, G, maybe it is 2. Level of H is 3. So level of H is 1 more than its parent level. Parent is F. F level is 2. 2 plus 1, 3. So here we have find level of all the nodes. So what is the level of leaf nodes? Level of D is 2. Level of E is 2. Level of H is 3. Level of G is 2. The maximum level of any leaf node. So there are 4 leaf nodes. The largest level of leaf nodes is 3. So depth is 3. Depth is 3. Or you may say height is 3. Depth of binary tree or height of binary tree. So the largest or the maximum level of any leaf node, the maximum level of any leaf node is considered as depth of binary tree or height of a binary tree. In this example, the depth is 3 or height is 3, because in these 4 leaf nodes, there are 4 leaf nodes. The leaf nodes, we have identified what is the level of leaf nodes. The largest level is its depth. So H is having 3. 3 is the largest value among the level of 4 nodes. So 3 is depth or 3 is height of a binary tree. Strictly binary tree or full binary tree. Strictly binary tree is a binary tree in which every non-leaf node is having exactly 2 children. In a strictly binary tree or a full binary tree where there are n number of leaf nodes, it may contain 2 into n minus 1 number of nodes. The total number of nodes may be 2 into n minus 1, where n is number of leaf nodes. Let me explain this with some examples. Say, let us have two examples, example 1 and example 2. Example 1. This is a binary tree. This can be considered as a strictly binary tree because non-leaf nodes are having exactly two children. So we should know what is a leaf node. Leaf node is a node which is not having any children. In this particular binary tree, B is a leaf node, D is a leaf node, E is a leaf node. A and C are non-leaf nodes. So there are two nodes which are non-leaf nodes. There are three nodes which are leaf nodes. So in these two non-leaf nodes, they are having exactly two children. A is having left child and right child. C is a non-leaf node having left child and right child. So this is a strictly binary tree. So what is the definition in a strictly binary tree where there are some number of leaf nodes and there are some non-leaf nodes, and all non-leaf nodes are having exactly two children. A, C are non-leaf nodes, they are having two children. Then what is the other thing? If there are n number of leaf nodes, it may contain 2 into n minus 1 number of nodes. See here, there are 3 nodes. The number of leaf nodes are 3. The total number of nodes will be 2 into 3 minus 1. 2 into 3, 6. 6 minus 1, 5. So there are 5 nodes. Whether there are 5 nodes or not, A, B, C, D, E, 5 nodes. Yes, it is correct. Let me explain with another example, example 2. This is also a binary tree where A is root node and there are some other nodes in distributed in left subtree and right subtree. There are some number of leaf nodes, some number of non-leaf nodes. Leaf node means a node which is not having any children. So B is a leaf node, F is a leaf node, G is a leaf node, E is a leaf node. There are 4 leaf nodes. Leaf nodes are 4. What are non-leaf nodes? A is non-leaf node, C is non-leaf node, D is non-leaf node. There are 3 non-leaf nodes. These 3 non-leaf nodes are having exactly 2 children. See, A is having left and right subtrees, C is having left and right subtrees, D is having left and right subtrees. So, the all non-leaf nodes in a binary tree is having exactly 2 children, then that particular binary tree, you can say it is a strictly binary tree or a full binary tree. So this is a full binary tree, or you can consider this as a strictly binary tree. And the second one is second property is, if there are n number of leaf nodes, it may contain 2 into n minus 1 number of nodes. So there are 4 leaf nodes. Number of leaf nodes are 4. So total number of nodes will be 2 into 4 minus 1, 8 minus 1, 7. Let me check whether there are 7 nodes or not. A, B, C, D, E, F, G. Yes, there are 7 nodes. So this is a strictly binary tree, or we can consider this as a full binary tree also. Complete binary tree. A binary tree is a complete binary tree if all levels are completely filled except last level. Even in the last level, keys should fill from left to right. Let me explain with some examples. Let us take a first example. Example 1. This is a binary tree. It is having some levels. Say a root node. Root node is having level 0. Then its children. So normally level of any other node is one more than its parent level. So level of B is 0 plus 1, 1. So BC, level of BC is 1. Then level of next node. So level of D or level of E, level of F is 1 more than its parent level. The parent is B, B level is 1, 1 plus 1, 2. So this particular binary tree is having 3 levels, level 0, level 1, level 2. So in the definition it is shown that the levels are filled from first level to last level. So there are 3 levels. Level 0 is filled, completely filled. Level 1, there is a possibility of having 2 children, 2 values or 2 keys. 2 keys are filled. In level 2, that is third level, again keys are filled from left to right. So only the last one is C right. C right is null. So level is filled from left to right. Last level is also filled from left to right. So one more gap is here. There is a possibility of having one more node here. So even then it is said to be a complete binary tree. Now let me explain another example. Example 2. Here A is at level 0, B and C are at level 1, D, E, F, G are at level 2, and H, I are at level 3. So there are 4 levels. All levels from 0 to 3 are completely filled except last level. Again in last level, the keys are filled from left to right. And there is a possibility of having a node left of E, right of E, left of F, right of F, left of G, right of G. So in the last level, the nodes are filled from left to right. After last node, there are no nodes. So before last node, there are no gaps. So this is also you can consider as a complete binary tree. See one more example, example 3. In the example 3, again it is a binary tree. A is root node, its level is 0. B, C are children of A, its level is 1. Then D, E, F, G level is 2. H, I, J, K, L level is 3. So all levels, level 0 is completely filled, level 1 is completely filled, level 2 is completely filled, level 3 is filled from left to right. There is some gap. So after L, there is a possibility of having one more node. So it is null. G left is null. G right is null. Whatever the nodes you have filled, they are filled completely from level by level and left to right. So that kind of binary tree is said to be a complete binary tree. Perfect binary tree. A binary tree is said to be a perfect binary tree if it satisfies two conditions. The first one is it should be a strictly binary tree, and the second condition is all leaf nodes should be at the same level. In every level where level number is L, it should contain 2 to the power L number of nodes. Then that particular binary tree is said to be a perfect binary tree. Let me explain this with an example. See, this is a binary tree where A is root node and there are some other nodes distributed in its left subtree and right subtree. See the levels. A is at level 0, B, C are at level 1, D, E, F, G are at level 2. What are leaf nodes? D is a leaf node, E is a leaf node, F is a leaf node, G is a leaf node. So the definition of a perfect binary tree is it should be a strictly binary tree. First one, it should be a strictly binary tree. So strictly binary tree means all non-leaf nodes are having exactly two children. Let me say whether this particular binary tree is a strictly binary tree or not. Leaf nodes are for A, B, C are non-leaf nodes and non-leaf nodes are having exactly two children. So it is a strictly binary tree. And all leaf nodes, the second condition, all leaf nodes are at the same level. So all leaf nodes, so leaf nodes are for all leaf nodes having level 2. So leaf nodes are at the same level and it is a strictly binary tree. So in a strictly binary tree and where all leaf nodes are at the same level, it is said to be a perfect binary tree. Perfect binary tree. In a perfect binary tree, at every level there are 2 to the power L number of nodes. See, level 0, it is having 2 to the power 0 number of nodes. So 2 to the power 0 is 1. So at level 1, at level 0 there is 1 node. At level 1, 2 to the power 1 number of nodes. 2 to the power L, level is 1. 2 to the power L, 2 to the power 1, 2 number of nodes. So at level 2, there are 4 nodes. 2 to the power 2, 4 nodes. The total nodes is 2 to the power 0, 2 to the power 1 plus 2 to the power 2, 1 plus 2 plus 4, 7. There are 7 nodes in a binary tree, that too a perfect binary tree. So a perfect binary tree is a binary tree which satisfies two conditions. The first condition is it should be a strictly binary tree. The second condition is all leaf nodes should be at the same level. So this particular binary tree is a perfect binary tree. One more example. So Let me check whether this particular binary tree is a perfect binary tree or not. This is a binary tree where there are some number of nodes. First node is root node. And what are leaf nodes? H is a leaf node. I is a leaf node. Like this, there are so many leaf nodes. Check whether it is a perfect binary tree or not. So it should be satisfying two conditions. One is strictly binary tree, the other is all leaf nodes are at the same level. So A is a non-leaf node which is having two children. B is non-leaf node which is having two children. C is non-leaf node which is having two children. D is non-leaf node which is having two children. E is a non-leaf node which is having two children. F is a non-leaf node which is having two children. G is a non-leaf node which is having two children. And the remaining nodes are leaf nodes. All are leaf nodes. So all leaf nodes are at the same level. So it satisfies both the conditions. All non-leaf nodes are exactly having two children and all leaf nodes are having at same level. So there are four levels: level 0, level 1, level 2, level 3. At every level in a perfect binary tree, at every level there are 2 to the power L number of nodes. So level 0, 2 to the power 0, 1 node. At level 1, 2 to the power 1 number of nodes, 2. At level 2, 2 to the power 2 number of nodes, 4. At level 3, 2 to the power 3 number of nodes, 8. The total number of nodes will be 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3. It is 15. This we can calculate with some equation. The equation through induction. So 2 to the power 0, 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3, etc. 2 to the power d. Suppose where depth is 3. So here height or depth. Height or depth is 3. In this particular binary tree, a perfect binary tree, the height is 3, where it is 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3. Suppose if depth is d, in general, it will be 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus etc. up to 2 to the power d. So this can be calculated like this: 2 to the power d plus 1 minus 1 using induction. So here depth is 3. In this particular example, depth is 3. 2 to the power 3 plus 1 minus 1, which is 2 to the power 4 minus 1. 2 to the power 4 is 16. 16 minus 1, 15. So even with the induction equation, we got 15. Or if you calculate by adding all these level number of nodes, you can get 15. So both are equal. So a perfect binary tree is a binary tree which satisfies two conditions. The first condition is it should be a strictly binary tree. The second condition is all the leaf nodes should be at the same level. What is strictly binary tree? All non-leaf nodes are having exactly two children. So check the binary tree first of all whether it is a strictly binary tree or not. The second condition is check all the leaf nodes are at the same level or not. If the binary tree satisfies both these conditions, you can say it is a perfect binary tree. Thank you.